Hello and welcome to Between Two Servers, the show where we talk about multiplayer game development and netcode. With us today is Ben from OneQode, and we're going to be doing a special episode today where we do a deep dive into how the internet really works. Welcome to the show, Ben.
Thank you. Thanks for having me on again.
So basically, Ben and I chatted in a previous episode, and I was like, "Man, we got way more to talk about." So let's look at it. Let's look at our two backgrounds as sort of like a really good contrast here, because Ben, you're not a software engineer.
No, I can't code my way out of a wet paper bag.
Do you even write code?
I write configuration files. So the closest thing I'd ever get to coding would be like writing a config in a router or a switch. Yeah.
Got it. So your experience is completely foreign to me, because my whole experience is as a software engineer, and I'm the guy writing the UDP packets that go over networks like the one that you make. And yes. You've forgotten more things about network engineering than I've ever known. And from the flip side, I know a lot about how games send and receive like UDP packets, what we're putting inside the packets, what we're sending and why, and what we need from the network. So let's drill in. So I'm a game developer and I'm using UDP, right? So of course I'm using UDP. Let's now look at the game. It's running, it's sending 60 packets a second up to the server. Hey, maybe it's receiving 10, 20, 30, 60 packets per second down from the server. Okay. From a game developer point of view, I'm just assuming that the network is going, oh, it's UDP traffic. It's not TCP. It's probably latency sensitive. It's going to deliver at the lowest latency, the lowest jitter, and the lowest packet loss route. This is my naive assumption of 10 years ago. So I'm firing off these packets. Tell me a little bit about what really happens between the client and the server from a network engineering point of view.
A lot happens. So some games, not yours, but we have noticed some games will even put QoS marks on there in an attempt to ask us to prioritize their packets over others.
Does it do anything?
And I can honestly say that I've never worked with an ISP has ever honored a single what we call a DSCP QoS packet. But some games do.
You're talking about the terms of service bit in the IPv4.
Yeah. So your DSCP
it doesn't do anything.
Bits,
no, it doesn't do shit.
And at some ISPs, we even went to the extreme, and we actually set all of our ingress ports, so all the ports coming in from the customer, to dump those bits off, so to lock them off the packets. So if you think of it like as a production line, we're looking for all those QoS, and we just go chop, and just knock it all off.
This
and then others
QoS
will just
stuff
like,
we put in, you just ignore it. Every ISP ignores it. Not only do you just ignore it, you actually strip it out and pass the packet on.
Correct. Yeah. So sometimes we strip it out, but other times other ISPs will just have they'll just go into the what we call the core fabric, and they'll just type no DSCP honor, bang, gone. So that means that we will never honor any of those packets. So all these guys out there, all these VoIP providers, game providers, especially trying, if I show them a QoS
Zoom tags packets, Zoom puts the tagging on, Network Next puts the tagging on. There's a thing with DOCSIS 3.1 where potentially it might help a little bit between your device and your Wi-Fi router, or the Wi-Fi router and the head end, theoretically on a next generation DOCSIS network, but really it does nothing.
I can say in Australia on the DOCSIS network, the NBN actually lops them off, because NBN uses the packets, the DSCP marks themselves.
So it's sticking stuff in there for its own purpose.
Correct. Yeah. So some ISPs use them themselves. Like, for example, you might have in NBN world, we have traffic classes. So TC4, traffic class 4 is general broadband, but there is actually what we call a TC2 and a TC1, and they're limited. Like TC1, I think, is like 25 kilobits a second you're allowed to push over on that priority. And TC2 is like 2 megabits, enough for a voice call. Okay. So we can actually buy different NBN speeds at different priorities, but once again, in my experience, almost no one uses TC2, maybe a hospital.
But as an application level developer, to touch it, no. I can't touch it, because I don't have a way to tag my packets in such a way that you, the network operator, is going to go, I believe what this guy's saying.
Correct. Exactly.
I mean, how would you know?
That's a trust thing, right?
Everything is important, right?
That's it. It's a trust thing for the network operator too. The problem is, once people figure out you honor it, everyone thinks that they are special, that they are important, which comes down to something I think we've both said to each other once before, which is the internet doesn't care about your game. We'll just get that out right now. Like network engineers, the amount of times people said to me, "Oh, but you're a gamer." I'm like, "Yes, I'm a gamer, but the gamers don't pay my bills." So for a long time, I had to focus on what paid the bills, which was the boss man who said.
And let's face it, like the gaming is a very small percentage of traffic overall.
Oh, and gaming traffic, even the busiest of the busiest providers, they're only pushing less than 10 gig because if you do the maths, depending on the game, like a game like CSGO, you can fit 1 million players inside a gigabit. Like it's like gaming traffic is very low traffic level. The only time the QoS works is a lot of consumer routers might honor it. So what it'll mean is that if you're playing a game,
also someone else is on your router,
your family member is thrashing Netflix, then the router will go, oh, hang on, I'll prioritize his 10 League of Legends packets because they've got a DSCP mark. That's the only time it works. And I think that's why a lot of game devs still put it in there, just on the off chance it does work.
Yeah, we do it. We use it. Yeah.
Yeah.
I assume that it hits the head end of the cable network or whatever the equivalent is for the ISP, and it does nothing.
It doesn't. And like I said, and in some places like NBN, I believe in Singapore as well, some providers, they actually chop it off at the router level. They actually have a TR69 message they send to your router to remove it before it sends it into the network. So
what happens now? It goes to the head end, an ISP, right? Like one of the ISPs that's not OneQode, right? Yes. What's going to happen to that packet now? It's one of the UDP packets. I'm sending 60 packets per second. Yep. It needs to get to the server somehow, but the server is not on the ISP's network. So what happens?
Rarely it's something like there's a very small chance it is, but especially in America or Australia, the UK, it definitely won't be because ISPs generally don't do anything else, right? So the first thing that's going to happen is it's going to come in what we call through an aggregation router. So that'll be like the edge of the ISP's network that connects to the last mile. It'll come in that router. That router will see it and then go.
This is the head end in the American terminology.
Yes.
And this is where all of the non-IP traffic is kind of terminating and turning into IP traffic.
Yes. Yeah. So this is where, like, if you're on cable or DSL, this is where your traffic is getting translated or on a modem, which is demodulating the information into a packet, IP packet, and then getting dumped onto the ISP's backbone.
Okay. So let's talk about that ISP backbone. What's going on there?
So then the ISP backbone, a lot of consumer ISPs think of it like a highway that they don't want you on. Like it's the complete opposite to what a highway should be. They don't want you on there for long. Okay. They want you to get to the nearest exit and get the hell off.
Okay. So this is called hot potato routing.
This is called hot potato routing or pass it forward routing, or there's many ways to explain it, but essentially
throw the packet over the wall routing.
Yeah, if you thought of it as a room full of people who are sharing letters, the idea of a hot potato is if you have two guys beside you, you try and throw all the letters to them, no matter where they're going. You just throw them to them and hope they'll know where to send them.
It might be even the wrong direction as to where the letter needs to go, but you're just like, I just want to get this letter out of my hands.
Correct. And in this case of some smaller ISPs, regional ISPs, it might be so hot potato that they only have one upstream. So they only have one other provider they connect to. And they just.
So what's an upstream?
An upstream is another provider you're connected to. So the internet is broken into tiers. So you got like tier 4 ISPs, or tier 4 networks, which are down the bottom, and they're little tiny networks who just connect to one company. Then you've got your tier 3s who sort of connect to 2 companies and maybe an IX. And then you got your tier 2s who have their own backhaul, and they usually have multiple sites, so they have multiple cities.
Okay, so backhaul is their own links between physical points of presence. So they might be in
California, for an example, and they might be in Los Angeles, San Diego, Portland, and Seattle.
And they've actually got the fiber, the waves, the dark fiber, whatever. They've actually got physical links where they're going to hold the traffic from one point to another.
Correct, and there's a class of ISP who we call backbone providers. And a lot of those backbone providers don't actually operate an IP network. What they do is they just build lots of fiber and they slice it up into pieces and then sell the slots off to everyone to then connect their cities. And what we call that is an intercap, so intercapital link. Now in Australia, we say intercap because 80% of the country lives in capitals, right? But in America, it doesn't really apply because the
major metro areas like
they
Los
link
Angeles,
intercap
Chicago,
links, That's
Dallas,
it.
Virginia, New York. That's sort of stuff.
Anywhere that's got a major international airport, you would say like intercap link runs between the two. Okay. So the backhaul, the backbone, the intercap, all the same thing. It's just a really fast fiber link between 2 places. And it can even be a fiber link under the ocean on a submarine cable, which we'll get into later.
Right.
So a tier 2 will actually have either their own they built, or they will be buying buying capacity on a backbone and usually taking out something we call an IRU, which is indefensible right of use for 20 years, which means for 20 years they own the cable. Even if the cable gets sold to a new owner, the new owner has to honor it and give them the access to that cable.
It's like when you buy a building, but it's got a whole bunch of microwave equipment on the roof.
That's it, exactly.
You're locked in, guys. It's not going anywhere.
Exactly. And then your tier ones are your really big ISPs. I believe level 3, CenturyLink, Lumen, whatever they're called this week, they are Lumen. A tier 1. Yep. Then you've got AT&T, they fall in the tier 1 category. In Australia, you would say Telstra is almost a tier 1 now, mostly because they own so much capacity. Like they own most of the backbones in Asia. They have quite a big presence in America now. They have quite a growing presence in Europe. You've got your likes of Verizon, they would be a tier 1 as well. You've got and tier 1s, they don't. So we have this thing called transit, which is where as a provider I buy internet from a tier 1.
Right.
The tier 1s don't buy transit. It's sort of like an exclusive men's club.
They're in the tier 1 club and they're peering with each other, a free peering.
That's it. Yeah, they all agree to peer with each other so that they all get to make more money. So once you get invited to the tier 1 club, you stop paying for transit because then you all just have these big fiber links between your networks in strategic cities together.
Okay. So let's now go back to the example. I'm a game developer. I'm sending my packets from the client to the server. But let's start from that tiny one.
Yes.
Start from that tiny ISP, the tier 4.
Yeah, your tier 4, so your baby ISP. So they've hit the head end. Yep. And a tier 4 is just going to have an upstream. So he's just going to have a head end into his core router, and his core router is just going to go flip and just throw it to the upstream, who would in a lot of American cases be AT&T. They're sort of the big. They're cheap, they're reliable, they sell you fiber, they've got small business specialists who will hold your hand and say, it's okay, you're an ISP, I'll help you get there.
Okay. So but here's the thing, and this is the important part for the game developer. What does the relationship look like from that tier 4 ISP to the upstream provider that they're throwing the packets off to? Do they have any guarantee from that upstream provider that it's going to go a low latency route or not going to be congested?
No. So IP transit, which is the stuff that the tier 4s and tier 3s buy, and even some tier 2s or whatever you call OneQode, because we sort of sit between 1 and 2. The transit stuff you buy, the SLA is about uptime and it's about reachability of the internet. It doesn't ever include latency to destinations, and it doesn't ever include hop counts, or it doesn't ever include guaranteed interconnection with other parties.
It's literally like you can send a packet here and it might get to it. If the internet can route to it, it's probably going to get to it, but I have no guarantee of quality whatsoever.
No.
And this is where your ISP is sending your gaming packets.
Correct.
Okay. Now let's walk up. Now let's look at a level 3 ISP. What is the level 3 ISP going to be doing?
So a tier 3 ISP, they're going to have things like peering. And they're going to be on internet exchange points, which is good because a lot of game companies are on IXs. And what that means is they can set up what we call a bilateral peering arrangement with the game company if they want to peer.
Okay, so let me say, like, I'm Riot and I have Riot Direct. I probably have something where I can peer with these
correct
tier 3s and IXs.
Yes. So Riot Direct is essentially where Riot went, we are sick of ISPs having bad latency. So we're going to buy from those backbone providers our own private fiber links all over America to every IX, to every carrier hotel, which is essentially...
So the carrier hotel and the IX is where these ISPs kind of go, I'm going to upstream to Riot Direct rather than throwing it over the wall with some sort of like no guarantees.
Riot Direct is rarely the driving point. It's usually Netflix is why they go there. But Riot is in the room, so they get connected. So the carrier hotel is a data center, which is usually more focused on giving every telco a couple racks to set up an outpost of their network. Okay. And they're usually well connected. They have lots of fiber going into them.
So it's not like the tier 3 ISP has to go and explicitly peer with Riot.
No, it's that because they're on the IX.
Because everyone in the IX on the route service. Okay. So everyone's having a free for all love fest in the meet me room. And if you've got an ASN and the packet's going to that ASN, it's just going to go the right way. Is that correct?
Hopefully. So the way an IX works is, if you think of it like as a big room with group chats, and what happens is, or telephone directory, an IX has a telephone directory. Now, some people on the IX will elect not to list themselves on the telephone directory. They'll privately reach out to other members and peer with them.
Okay.
But a lot of members will just go to the telephone directory and say, here's my AS number, here's all my IP addresses.
Just let it in. Let's go.
If you need to send me stuff, just dump it to my port on the IX and I'll take care of it. And then Riot usually does that. So what that means is any tier 3 ISP on an IX will then immediately have better routing to Riot.
This is
depending on their routing to that carrier hotel, right? But
this is a
doesn't always
massive investment from Riot to make it so that these tier 3 ISPs can effectively say, I'm going to throw packets your way and you're going to take care of them. And it's not something that a normal game developer can be doing usually.
No, God no. God no. So
let's now look at the non-Riot Direct situation for a tier 3. What's usually happening for a tier 3 ISP when you don't have Riot Direct and you haven't set up your own ASN and all these internet exchange points?
So the tier 3 is still back in tier 4 land. The only difference is that the tier 3 might have 2 or 3 transit upstreams. So you have a slightly better chance. Well, So option A is it doesn't. It does what we call round robin. So it just half, splits it in half. So just 50, think of it like as a spinning bottle, and then with the packet shooting at the end, and then there's just 3 holes and it just shoots
I've
into each
seen this
hole.
because often these different upstreams have different characteristics. And depending on what port number or IP the server has, or the ephemeral port on the client is, they often, and again, I'm not a network engineer, but from an application software point of view, I've seen differences of 10, 20, 50, 100 milliseconds just by shuffling the source test IP addresses or the port numbers. And I assume that inputs into this round robin decision.
It does, yeah.
Okay, well, that explains it. So randomly, these 3 routes with different performance characteristics, and remember, all 3 of them don't have any guarantees of any actual quality, right? But they're all assumed, they're all basically the same. I'll randomly pick one of the 3 and send the packet up that way.
Correct.
Okay.
So what the router does is it looks at the traffic and it looks at what we call the IP header, and it goes, it's going to this IP. And some guys might run what we call odds and evens. So if the IP at the end of the number at the end of the IP is an odd number, it goes to one upstream. If it's an even number, it goes to the other one. And then there's odds and evens, bang, split in half, away you go.
Modulo n, where n is the number of upstreams and a hash of the source.
That's it. Yeah. And then they have what we call a connection tracker, which then means that it remembers that every single packet for that.
So here's a live connection. So don't be like flapping at different directions.
Correct. It won't move that
always
that
go
connection
that
from
way.
your house. Yeah, but if you're playing LOL and then like say your partner's playing LOL beside you,
if you're wondering from one session to the next
ways.
why you get completely different performance, it's because you might now have a different ephemeral port number, and now instead of going left, you're now going right. It's the same exact server in the data center, and you've got the same connection as a player behind an ISP, but this randomization between different upstream providers from your ISP is randomly adding latency from one match to another, giving you inconsistency.
Correct.
Yep.
Yeah.
I've seen it. Okay.
Yeah. So
tier 2?
That's
or
tier 2. Yep.
What is a tier 2 going to do?
So a tier 2 ISP will generally they're now in backhaul territory. So for example, let's take who's a tier 2 in Australia or America. I don't know many tier 2s, but a tier 2 would be like a state-based ISP. So they'll be in they'll be in Portland, they'll be in Silicon Valley, they'll be in LA, they'll be in San Diego. Yeah, they're a regional ISP, right? Okay. So what'll happen is they're in all these cities down the West Coast, and they'll have fiber between the cities. They'll have
First Light is a regional Northeast USA ISP, and I presume that they would be a tier 2.
Yeah, I would presume they are.
First Light fiber. Yeah.
Yep. Yeah, so they'll have fiber all the way up the West Coast, and they'll be in every city. They'll be in every carrier hotel in every city because it's cheaper to peer than to buy transit.
They're just in this one regional area, and they're not going to be in every major metro in a country or have international.
No, and they're not going to be in like for example at OneQode, we're in like every major IX in Asia Pacific, right? So we're in Los Angeles, Seattle, Brisbane, Sydney, Melbourne, Tokyo, Hong Kong, Singapore, Guam. Like it's a long list. And it's a lot of network engineering because you've got to millisecond millions and millions of routing information you're receiving every second, and then make sure that you're sending the traffic in the right direction, or else you cause a 200 millisecond on someone, and then they complain.
Like a hairpin. Yeah. Okay, so back to the tier 2. So
back to the tier 2.
They can't really necessarily on their small regional network take it all the way to where it needs to go because say the server's on their side of the country.
Correct, but generally they'll be peering in a lot of IXs in their region.
Okay.
And a lot of backbone ISPs will also be peering in those IXs. So
Okay.
the hope is that generally you'll get a slightly better quality of internet, because the game developers usually buy from the likes of AWS or Google at the moment, or any of these other infrastructure providers. And the infrastructure providers generally try and peer everywhere because it's cheaper than buying transit. It's cheaper to buy backhaul fiber and IX peering than it is to buy transit at the same dollar per megabit.
So effectively, let's talk about this peering arrangement. So the tier 2 ISP is basically saying, I don't have the network to go all the way to the server, but I'm peered with a bunch of other networks, and you're effectively saying, hopefully the hosting company running your servers, or yourself if you're Riot Direct or whatever, has set up some sort of a way for BGP to work out, I need to get it to this ASN, and it's going to hopefully take a good path. But there's really no guarantee, is there?
We're still not like, and honestly, even when we get to the tier ones, there's never going to be a guarantee. There is no guarantees on the internet. Because we don't operate that way, because it's all best effort.
Best effort delivery, meaning
especially for residential. So especially for residential internet, for that modem on your wall,
for everybody playing a game. Best effort delivery applied to every packet sent by a game you're playing.
That's it. And you're paying between $30 and $120 a month. That's not enough. If you think of the average salary of a network engineer is over $100,000, that's not enough for the ISP to commit a network engineer to actually make your lag go away as a user.
Right.
As long as you can play the game, they don't care if you're at 20 or 100 milliseconds.
So effectively,
as far as they're concerned,
now we got tier 2, and I'm gonna assume that the tier 1 is basically the same, except the tier 1 might have its own backhaul.
Actually, no, the tier 1 gets really tricky, because the tier 1 generally won't peer.
Okay, so we're talking Comcast and Verizon's here at this point.
Comcast, Verizon, Telstra's, Optus, Singtel,
the big ones.
NTTs. Just to give everyone who's watching a bit of
So you're not going to be like, I'm a game developer and I host with insert company here, and know that company is peered with these tier 1s, because they don't peer with them.
Correct. You've got to buy from them, is what I'm saying. So all these big
my God,
guys,
it's flipped the other way around. So now,
and now they're gangsters, right? Now they're monetizing their customers. They know that they might have 25 million customers behind them.
Okay.
And they go, well, no,
if you want access to these customers, you need to pay up now.
Yes, they toll both sides of the link, right? So they charge you to get access to their customers, and they charge their customers to get access to you.
Okay, so that's fine. So now at the tier 1, you've basically got aggregation of customers, and it's like, well, if you want access to my 30 million customers, you're going to pay me to interconnect with my network. Is this like the whole? Is this like that whole Netflix thing where Netflix had like really bad interconnection for a long time, and then everyone was playing?
Correct, because everyone tried to charge them transit, and Netflix put the middle finger up and said, "No, this is not how this works." And we now have this sort of middle ground where we have what we call paid peering. So it's nowhere near as expensive as transit. And if I buy paid peering from Comcast, they're not going to give me access to AT&T or Verizon. But that's in a lot of cases for gaming, that's a better result, because you don't want to buy from 1 or 2 transits and then rely on them to get you to other tier 1s, because generally the interconnects between the tier 1s at peak times get congested.
Okay. So let me sort of dial back a little bit here. Like, as a game developer, I don't have the ability to interconnect with Comcast and Verizon.
It's a lot of work.
I don't even have my own network, nor I have no idea what to do. Okay. I write code, it runs on a server. The server is hosted somewhere with a public IP address. Now I'm effectively in this situation saying, I really hope that the hosting company that I'm working with has good interconnects with the ISP of all these players. Is that correct? It's really the only hope that I have as a non-network engineer?
No. So I think this is why everyone's moving to the likes of Amazon and Google at the moment, because Amazon and Google have done a relatively good job of connecting to all these ISPs in all the cities they operate in, and building their own massive backbone links, and Facebook has done this as well for themselves. You've got the likes of, Riot have done it as well. But from your cloud provider
the server hosting company has to do it. And if there's 50 different server hosting companies, that's a lot of overhead for each of them to have a special deal with each major tier 1 ISP around the world.
I can honestly say already at OneQode, we do this, right? This is one thing we do, is we connect to every eyeball network we can. It is a lot of administrative work. It's a lot of overhead. It's a lot of money. It means that your barrier to entry moves at 0. up the column, because
Yep.
now you have to have all these connections that are all burning cash, and the fiber between you and the carrier in the data center costs money per month. The switches cost money. You need bigger switches. You need
And
bigger
you're paying
routers.
for this. You're paying for this even if no actual game traffic is going across it.
Yeah, well,
This
like for example, one of our interconnects with a major provider in America right now is essentially idle,
Okay.
and they don't care. They still charge me.
Okay, cool.
Like,
so this is not particularly a situation where let's flip it around now and go like, what do we really want for games, right? Like let's look what motivates you and what motivates me. I really want game traffic to be treated a little bit differently. You know, maybe the best effort delivery is great for most of this non-real-time sensitive activity that I'm doing on the internet, like downloading a web page. It's working okay, right? But when I'm playing a game, I kind of want to be able to tell the network, hey, come on, these packets are different. Treat them appropriately, you know. And that's why I created Network Next, at least, as a way for me, the application developer, to kind of say, hey, network, hey, here's the important stuff, but not in a way where I'm setting the TOS bit and you're just going to strip it. But like, no, you can cryptographically now. Obviously, this is the thing that is, you know, in development and will take a long time to work with all of these different operators. But our technology makes it possible for network operators to look at the packets belonging to a stream, you know, or a flow coming from a particular user of a game and go, I can identify the packets that belong to this flow cryptographically and determine if they're real when paid, and I can treat them differently potentially and get paid for it. So this is radically different from the way that ISPs work right now.
It is. It's a totally different way to approach the internet.
Right. So now let's go back to OneQode, because you guys are doing the same thing, but you have a different strategy. How are you doing it?
Yeah. So our methodology is we don't build to price.
Right.
So a lot of ISPs will just find the lowest bidder within the margins that they want. So within the margin of, you know, technical requirements they'll just take the cheapest bidder. We don't do that.
You're now saying I care about quality as I build out my network.
I care about latency. So we pick, you know, submarine cables, backbones based on the lowest latency figure within a margin of like reality. Like if someone's going to charge me obscene cost to shave a millisecond off, we won't pay it, just because we know our customers won't pay it, right? Because it means that all our servers go up $50 a month. They go, oh, I don't want to pay that.
Everyone acts like a millisecond is important, but the reality is, at least in my experience with game developers at Network Next, it starts becoming meaningful, I think, around 20 milliseconds reduction.
Yeah, so we work with 25. So I think we're in the same place. Yeah, so we work, if it's a 25 millisecond saving, then it'll be worth the extra
you can feel it
a month. Yeah.
Another way to look at it is because the games are often running discrete frames at 60 FPS. So each frame is at least 16.67 milliseconds. So honestly, if you're saving 1 millisecond, it's probably going to get quantized to the next frame anyway.
Exactly. And the only time you might see this be different is in your, what we call your high tick rate games. So Counter-Strike, Valorant. I believe Battlefield 4 was 144 tick. So and I believe even the newer Battlefields now go all the way up to 165 tick. So
that's a lot of fucking packets per second.
And the thing is,
never shipped a game more than 60.
And the thing is that the tick rate has massive effects, because it means that you become more sensitive to jitter on your network. It means that you have to have a faster computer, because tick rate actually means that the CPU has to work harder. I don't think people realize this.
Yeah, big time.
And all of a sudden, you know, gigahertz start becoming a major factor. And if the game feels smooth, because tick rate is almost always a single threaded calculation.
There's a cost thing from the game developer point of view, because if I'm going to run servers at 10 hertz or 20 hertz, which is a pragmatic option, and there are ways to make it depending on the network model that I'm going to do for a game, there are ways to make that feel a lot like 60. Well, but the servers now, on my game servers, if I'm running 60 hertz ticks rather than 20 hertz ticks, I'm going to be spending 3 times more on my servers now, because I'm running
you can fit less people per server, and you need to buy faster servers from the outset, because if they're going too slow, you'll just never do the tick calculation.
I'm running 20 ticks per second, or I'm running 60. It's 3 times the work.
Exactly. Right? And the tick rate also has a massive impact on the network. So for example, when we ran a CSGO tournament on our Guam servers, even 4 matches concurrently is over 100,000 packets per second across the players. Comparatively, we might have a daily community server running, and they'll never even scratch 5,000 packets per second, and they have more players online. The tick rate really, like for every tick rate jump, it's exponential the number of packets your computer is sending.
The pros in Counter-Strike as well, they jack the tick rate up massively. They're running at really high frame rates on the client. The tick rate on the server is really high. And
they also use client commands to force extra, which causes it to send every packet like a fire hose. So what that means is that we see about 100 to 150,000 packets per second during a CS:GO match. Like it's a lot of traffic.
That's a lot. Yeah, very cool. Okay, so we've gone through all the different tiers, and we've pretty much established that the ISP is kind of throwing the packet over the wall and going, just send it in the general direction, but I don't have any guarantee that it's going to get there. There's no coordinating sort of authority kind of going, I think this game packet is special, and let's pick the low latency route for this game packet. It's just not happening.
No, there isn't.
This is why we find these big latency reductions with Network Next, because all we're doing is we're basically going, oh, whoops, they rolled the dice and they got the wrong upstream, and that's the low latency. That's the high latency upstream, and take the low one. Or we have a way to sort of subvert the way that the packet would normally go to make it go a particular way, right?
Correct, yeah. And from a networking standpoint, by the looks of it, part of what you do is by having nodes, your Network Next nodes everywhere, means that you might have a way better path to your node than the game server. And then your node in turn has a better path to the game server. So you can then just tell the client to redirect the packets to my node, and I'll handle it, and I'll carry it. That's what we do.
And when I work with you guys at OneQode as well, like let's say there's a recalcitrant ISP it's not, the player isn't a OneQode player in Australia or whatever, but the recalcitrant ISP is sending along their own, whatever, one of their upstream providers, right? And it just happens to be a really bad route, right? Well, we can say, no. We can force them to take the OneQode network, which you've built.
Yes.
And
because we do this peering where we do try and connect to all the ISPs in their region,
kind of hope that those ISPs send it to you.
Or we can encourage
them. You can't.
We can encourage them. We can really encourage them these days because we are on the IXs, and because we buy the private peering with them. We sort of pay a small toll for them to guarantee they'll send us all the traffic.
So your hope as a network provider is, I'm going to go out there in all the IXs, and I'm going to advertise here. Like you want traffic that goes to ASN X? That's us. Send it our way. We'll take care of it. No cost to you, right? That's sort of effectively what you're saying to these ISPs. But they always can. They can misconfigure or not do it, or just not know about you, or just not be in that IX. And then the traffic takes a scenic route on its way to OneQode.
Sometimes, yes. And we're still seeing that a bit, especially with some of the ISPs we're not in their country yet. So once we get inside a country, like I said, we do actually pay the toll. We call the ISP and say, hey, how much for peering? And they'll go, what? We say, look, we will pay you to give us a fiber link to your network. And then we will send you the prefixes we want you to hit, and then we do a trick we call disaggregating. So when you see an IP address and it's got like that 255.255. blah 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 blah, that's what we call your subnet mask. Routers always prefer what we call a more specific route, so a smaller prefix. So what I do is I disaggregate all my addresses to the smaller size, and instead of sending them one big block of IPs, I send them 50 tiny blocks. So their router's going to go, oh, he's got all these really specific destinations.
So you guys look small according to the cost function that these other routers are doing to work.
No, we look cheaper. We look cheaper. So a smaller prefix is a cheaper routing option, right? So like, for example, if I send you what we call a /8, which is 10 dot, everything after that. So 10.1, 10.2, 10.3, all that is inside of 10/8. The router's going to go, that's a massive advertisement. So they've got a lot of networks behind them. But if I send you 255, 10.1,
I see. So from
10.
the ISP's point of view, it's kind of like, this prefix looks like a very specific prefix, which means it's more like I'm sending it direct to the destination rather than going through someone who is advertising a really big address space. Okay, I get it.
So we call it disaggregating.
That's how you get in front of the queue. Okay.
Yeah, we never do that on transits, and we never do it on IXs, but we do it on private peering, which then forces generally their router to go, oh, hang on, that's a more specific direction. I'm going to send all the traffic for them always over this fiber link. And it's what we call traffic engineering. It's that way I can then try and strongly encourage the guys to send me the traffic where I want to receive it so that I can carry it the shortest distance to the server.
Got it.
Lots of little
Well,
tricks we have to use to try and get these guys to play ball.
What's really interesting here is, and this is part of why I created Network Next, is like we have an SDK where we're in the client or in the server, because I don't want to fucking trust anybody with this routing. I want to measure it and steer it the lowest latency route, and I'm going to fucking force it. Right. That's, I mean, as an engineer, I'm like, no. Like, we could ask them nicely, or we could just make them do it. Right. So that's why Network Next has an SDK in the client and the server, is because we're forcing packets to go a particular way. And we're continually monitoring. And we basically, the way our SDK works is we're looking at this client is going to this server and the default BGP route, whatever is going on there. But our route is like 20 milliseconds faster or more, or whatever the customer says is important to them. Okay, now we're going to force the route to go the way that Network Next says to go, and we're going to override all of the BGP routing, and we're not going to play nice. We force it to go the right way. But what's cool is that we end up only doing this for like 1, 2, 3, 4, 5% of the traffic. That's the secret. That's the trick, because we're fixing the really shit stuff.
Yeah, you're fixing the real top end of that.
The hairpins, the messed up stuff. The people who are going all the way around, the people in Dubai who are going to Frankfurt and back to Dubai, just to go to a server in Dubai. We see a lot of those sort of things all the time. We're fixing people in China going to outside mainland China.
Yes.
But bottom line is, look, we've got all these different ASNs, different networks. Some of them are forcing other people to pay to even talk to them. Right. But when one ASN talks to another, it seems like the best that can happen is that one network says, well, that's a really specific prefix for that ASN. I'll send it that way at best. And there's nothing forcing that to happen and whatever. No. But maybe it's no wonder that we see 1% of people at any time having a pretty bad route. Right. So
no.
Ben,
no surprise at all.
I want to go out there on a limb right now and just say, I think that the entire structure of the internet is wrong for real-time traffic. I think everything from top to bottom, tier 1 through 4, the whole concept of best effort delivery is not what we need for real time.
No, not for real time, not for videos, delivery. Not for like computer gaming or the metaverse, whatever it's called this week, or even what we're doing right now. The internet is not designed at its core to handle this. It's designed at its core to connect everyone. Yeah, and then everyone's had to
at a best effort rate with like the packet will get there, maybe kind of. I make no guarantees. If there's a thermonuclear war, right, there's going to be cockroaches in the internet, and that's it, right?
Correct.
But I'm not going to give you the best latency when you play.
No, I'm not going to give you the shortest path, and I'm not going to even do the most logical thing you expect. Like you said, you've got players in Dubai going back to Frankfurt. We've got players in Mongolia going via New York to get to Hong Kong.
I call this internet weather. It's really weather, because see, when you look at any system, when it gets complex enough, a complex system has unpredictable weather, right? So I see stuff like when we see all the people on Network Next, right, all the players, and we'll see like a Friday night or a Thursday night, we'll see congestion in a particular region, and we'll see the routing just get weird, right? It's not like it's a fixed system that just works the same way all the time. It's like, no, there's a traffic jam or a weather pattern happening over here, but over here it's fine. And then it's raining over here and it's sunny over there. And this thing has unpredictable weather, right? And that's the thing I think people don't realize. It's like, not only is there a lack of incentive or even a perverse incentive for network operators on the internet today to kind of go, I want the cheapest way to send this packet over the wall. But there's also 100,000 different networks all connecting and misconfigured, and perverse incentives, and all this stuff is mixed up together to basically create the system that has weather. And that's why when you play on a Friday night, it's really bad.
The other factor is maintenance. And Friday night, and the other thing too is ISPs only do maintenance at nighttime. So we will plan all day long.
That's what we're playing, dude.
Well, we can't take the businesses offline. So you got to realize the business customer is the high value. So we got to, between 9 and 5, the network's got to be bang on, never dropping, no issues, which never happens. But that's the aim, right? That's the goal. It's the pie in the sky. So we do all that maintenance at nighttime, 9 p.m. and we start pulling out fiber links in the data center while we're moving switches or recommissioning links. And that's the peak gaming time.
Prime gaming time, dude. Yeah.
Correct.
Yeah, that's ridiculous. I've seen it so
often. It's Netflix time, it's gaming time, and that's when we do our maintenance.
Yeah, everything is wrong. It's just wrong.
But the thing is that when do you do the maintenance? And that's with the thing we've had. I've worked at ISPs where we've gone, look, we don't want to knock people off Netflix, so we go later. We go, oh, let's go midnight. Let's go 3 a.m. And then we start breaking everyone's backups because that's when everyone's backup systems are running.
Yeah, that's a tough one, right? That's a tough one.
So a lot of ISPs are getting better. So that's the thing is we now don't knock you offline, but your latency might jump 25, 50, 100 milliseconds while we've got the core link offline while we're fixing or recommissioning or moving something. So we don't take you offline anymore, but we just make your latencies a bit higher for a bit while we fix it and then we bring it back online again.
Because otherwise what would happen is that everyone would have to provision to have twice the capacity for every link that they possibly can have.
Yeah.
So that they could turn off half of it when they do maintenance.
Which we do try to do. Like all our backbones are redundant, but I can't have 2 redundant links to every provider because the provider is not going to want that, right? They're not going to want me to have 2 links to them, and they don't want to have double this capacity that I could possibly abuse one day on a bad day and cause all sorts of issues. Yeah.
Well,
exactly.
It's tough. It's tough building a network. So look, let's not beat up on the network engineers too much. Within the system of the internet, within ASNs and BGP, there are a lot of people out there. They're doing the best that they can, right? But when you're playing a game and you get inconsistent network performance from one game to the next, or it's good on Tuesday and on Friday you got a horrible route, you go into the same data center. We now know what's going on. So Ben, look, let's think about the future now. Like if you had a magic wand and you could fix something and change how everything works regarding how these networks talk to each other on the internet, what would you do as a network engineer?
I think more of as a network architect, I would actually go a bit regulatory. I would say that if you exist in a country, you must peer at least in one place in that country, because forced peering, as we've seen in certain countries, has dramatic effects on network quality.
It levels
by forcing
the playing
traffic.
field, doesn't it?
It does so much. And I would actually go one step further. I would say you have to peer on a non-profit IX, and you have to peer on the route server. So I would essentially somehow in a regulatory fashion force all ISPs to play nice.
Okay.
Because a lot of ISPs use interconnection as a bargaining chip with each other. They use it as a way to get, better commercial outcomes. They use it a way to, gatekeep entrance into the ISP industry by forcing small ISPs to have crazy startup costs. Like there's an old joke: if you want to become a millionaire, if you want to become a millionaire in telco, start with $1 billion. Like it's the running joke, right? It's very hard to get into. It's a very small club of people who know how to do it as well. Yep. So then it's just I think that's one of the biggest effects we could have is by forcing ISPs to peer in each country. And I would make it unilateral. If you want to operate in America or Australia, you must peer. It doesn't matter if you're Cloudflare, if you're Google, if you're Comcast, you must peer at XYZ. And you could even go out as far as to say, once you have XYZ, revenue, you must be peering in multiple states, blah, blah, blah. But just even one peering would be great. Just one.
So let's now hit a hot button topic, network neutrality. Okay, so there's like a lot of like light, and not a lot of heat out of a lot of the discussion around this. I mean, the way I look at it personally is it's kind of a weird thing, because on one hand, there's like, do I not want networks to act anti-competitively? Just like what you just said, like I want networks to interconnect, and I don't want people holding users hostage and extracting money, like that. That's sort of anti-competitive. I don't like the anti-competitive aspects of taking network neutrality away. But there's something about network neutrality that really irks me, which is it also seems to be bundled together, at least in people's minds, with the concept of, but all traffic is the same, or at least all traffic should be treated the same. And this is where I kind of hop off the train, because the traffic that I work with, real-time traffic, it's not the same. It's not the same, and it shouldn't be treated differently. What if we could find a way where we could treat real-time traffic differently, but in such a way that network operators couldn't act anti-competitively? That's what I want to create.
And I guess the other thing is, with the real-time traffic, do you want to pay more for that special treatment? Like, do the game developers, do the players, do they want to pay a bit more for that special treatment?
I think the players don't want to pay, but as a game developer myself, I know that I'm absolutely willing to go 1, 2, 3, 5% of my players are having an atrocious experience, and I can just pay some money and have it fixed with the caveat that I'm not being shaken down.
Yeah,
right?
of course. I mean,
It's
I don't
got to
mean
be
like
a,
shakedown pricing, but
it's
I
got to
mean
be
like,
like a
fair.
competitive price arrived to from a process of competition. I can
Mm,
fix it for this much. I can fix it for that much. I'll take the
mm,
cheaper route, but it's within my quality parameters.
correct.
That's the thing I'm trying to create with Network Next is I want 20 different ways to get from A to B, and then I want competition on performance and price, so that they're 10 routes that are all good. They're effectively competing on price to carry that traffic every 10 seconds. That's what we do at Network Next.
Mm,
It's like a replacement for this whole BGP interconnection thing, but it enables game developers to basically say, hey, look, my traffic is different, and I'm willing to pay a certain amount when the player's performance is outside of what I think is okay for my game. I'm willing to pay to fix that. But I got to make sure, like, the thing I have to make sure with Network Next is I've got to make sure that competition is driving the price. That's the thing that I think is so important. Like,
yeah, I
why?
100% agree with you. It does need to be at least somewhat transparent and a marketplace. And you generally
Mhm.
want the guy selling the fast path to be a neutral provider. You don't want it to be
Yeah.
like
Hey,
AT&T is the fast path guy, because then
if
he'll just be
someone
like,
has a
well,
unique fast path that no one else has, command the
mm.
price, right?
No,
Like,
no, no.
command.
I mean the person brokering these deals, right? Like it
Oh yeah,
doesn't.
okay.
Yeah, so you need this neutral authority to be deciding what is, or at least having the neutral marketplace. So the price, the market will decide the price in time.
Yep, yep, yep.
So I definitely think a real like, I love what Network Next is doing. That's why we work with you. But I think net neutrality. I think assuming that net neutrality means that all packets are treated, in this authoritarian way of everything must be treated exactly equal is a bit
It's a bit
daft,
weird, isn't it?
because
Yeah, because well, firstly, it's just flying in the face of reality because they're not. Like
they're not.
I'm watching Netflix. It's a bufferable stream that can
Mm,
just be delayed an additional 10 seconds, and it doesn't really affect my viewing experience in
correct.
any way,
Yeah. Or
right?
there's many other things like, net neutrality sort of also, it breaks these private peering relationships that networks can have, because then it says, well, no, you can't privately connect to that guy because you have to offer that to everyone. And it's like, well, as long as I'm peering on the IX, if I elect to then have a private fiber line to one other provider who's a mate, I should be allowed to.
Yeah, yeah. I mean,
So I think some of the arguments for net neutrality were a bit overblown, and I think maybe that was what scared everyone away. I think getting completely trashed was also a really bad outcome as well on the inverse.
yeah. I think there are
So
aspects of it that I mean, I don't want, people playing games to have to pay the ISP $30 a month for the gaming package and to be
well, that's
told,
actually coming out in Australia now. So
oh, it's
three of
horrible.
our major ISPs now have what they call a gamer pack, where they
I
do offer you
really,
better routing, or they might be the only prefixes they peer with, and they'll
it's
put you on
super
that
gross.
prefix
It's
for
super gross.
$25 a month.
These are people who are already paying money to their ISP, not
Mm.
not a small amount in their
No,
minds, right?
well,
They
it's not a
deserve a
small
quality of
amount.
service beyond, well, we're just going to route your packets terribly by default, and you're going to pay us more to fix it. That's
No,
creepy.
exactly. It's not a
Yeah,
small amount. $100 a month is not a small, insignificant amount to be spending.
it's a significant amount. It's more than the game console that you paid for, and it's
Exactly.
going
If
to
you're
an
spending
ISP that's saying, I
$12,000
want
a year,
more,
if you're spending,
right?
$1,200 a year on something, or $1,200 a year on something, you want to get your value out of it.
Yeah,
And if the ISP is saying to you, well, hang on, I can't do it for 100, but for 125, I can. You have to ask, but hang on, aren't you
oh,
charging the guy on the other
really?
side?
Yeah.
Yeah, aren't you charging the game developer to connect to me? Like, hang on, aren't you
This is
tolling
where we
both
go back
directions?
to what you guys what you and Matt said earlier. Is the rot goes deep.
It does, and well, that's it. Like, the CEOs of these telcos want to buy their third yacht. Like, that's their objective. Their objective isn't to give you internet. It's to keep the shareholders happy, and B, get that third yacht, get the second holiday
And
home.
I can fully understand it in the context of the vast majority of traffic by volume is this
Hmm.
non-gaming, non-real-time stuff.
But even
It's
the
a sort of a
non-gaming, non-real-time stuff is affected. Like, we saw it with Netflix for years, where certain
Mhm.
ISPs were purposely, breaking Netflix to try and hustle Netflix to pay them more money.
Yeah, that's not
Or
cool.
we see it.
That's the thing when I look at network neutrality and what I want to preserve from the network neutrality, it's like you and ISP shouldn't be able to shake down an application developer just to get good, decent quality of service. That's the
Hmm,
thing that I don't like. That's anti-competitive behavior, in my opinion. Right? Like,
hmm, it is.
yeah. But I'd like to find a way that we can do it where we don't have to have this little fantasy land where I'm checking my email and this person over here is playing CS:GO or Valorant or Apex Legends, and we're just going, it's all the same. It's not all the same. It's totally different, totally different. Absolutely a different type of traffic that should have a different performance guarantee. It should be routed differently. It should be treated differently from the computer to the router to the head end, from the head end all the way through the upstream, all the way to the server and back down. It should be treated differently to regular non-real-time traffic, but it's not.
No. So I actually have a question about Network Next.
Go for it,
flip the table here. How does it deal with VPNs? Because as we know, a lot of players, especially in Asia, use VPNs for, to get better latency.
Yeah.
And a lot of people will never know that Network Next is in their game because it's a silent actor in the back end, just, waving the magic wand. How will the player know to turn their VPN off because Network Next might give them a better.
What's interesting, we can often find improvement even when VPNs are turned on. But
the only issue I say is because a lot of VPNs run into VPN concentrators, which are incredibly congested, right?
Yeah.
So does Network Next have some sort of secret source that especially on Windows, it can switch adapters?
The VPN to us looks like somebody at a different lat long. The person looks to us like they emerge at the point where the VPN is concentrated.
Right. So you can't in the game engine select a different network adapter, because on Windows that's now a possible thing through the API. You can just switch adapters and you could check that adapter and hang on, now your second network connection is faster.
Yeah. I think that's a really good idea, Ben. And it's the sort of thing that it's something that we should try, but it's sort of like there's something about the user selecting and making an intentional decision. I want to play on the VPN. That it feels like if I'm undoing it, it's something that the user didn't really want. So generally when we work with, customers like ESL and other customers that we work with, there's often a period of trust where these people actually learn that the connection is better when they don't use a VPN or when they don't use a product like the Fast or Haste or all the other B2C accelerators. We can often actually do a lot better. And here's the thing, and this is the reason why Network Next is B2B. We don't know what 1, 2, 3, 4, 5% of players at any point in time are going to be the ones who need improvement. The reason why I don't like VPNs and I don't like B2C, because it's effectively saying, I'm going to charge someone, even if I don't know that I'm going to get an improvement for them at this point in time, I'm going to still charge them, $5, $10 a month, or the ISP. Yep. They can't know ahead of time that they're actually going to get improvement. Because it's a function of, it's the phase of the moon, and it's the ephemeral port number on the client, and the ephemeral port number on the server, and then the particular server instance and the IP address of that,
and the time of day, because if maintenance is on,
and
millions of factors, right?
All these things are inputting into the route, and then when you use an acceleration product like one of the B2C ones or Network Next, the improvement that we can provide is relative to how bad is the default route that you're taking. We can fix that. But if your route's already good, we can't fix it. So one of the things I like about Network Next is that it's a really ethical product, because we're not charging users for no improvement. Like, we might only be targeting 5% of players at any point in time. And I'll tell you, by the way, from one day to the next, it's not the same 5% of your players. That's the funny thing. It moves around. This is why it's like weather. It really, we've seen this with different games. It's consistent across the world. Everywhere in the world, it's the same. We could target 1% of players at any time. That ends up touching 10 to 20% of your player base over a month. It's crazy bad out there. But the reason why I don't like these B2C ones is they would take 100% of your players and say, I'm going to charge all of them $5 or $10 a month. And honestly, meaningfully,
a lot of the people we see,
half of them wouldn't see any benefit.
A lot of the people we see aren't using the B2C players. They don't like them. A lot of them we see are just using a generic,
just a regular VPN. Yeah.
And what they do, and the captains sit down at 9 a.m. if the match is at 10, and they test every, they'll have 20 subscriptions. They'll test every VPN
which one's
find the correct, the lowest latency.
Here's a way to think of Network Next. It's a virtual VPN integrated into the game that automatically every 10 seconds for every player works out not just which one of 20, but actually more like one of 10,000 different ways to get from A to B is the best for you at this point in time. That's pretty much what our product is doing. It's like a VPN wrapper that's included in the game. But when we work with people who are running external VPNs, we do our best but we can't undo it if the VPN kind of
Yeah.
the VPN is
I guess
makes you emerge.
even just like a very non-hostile, hey, it looks like you're using a VPN, maybe consider turning it off. We believe you'll get better latency. Pop up in the game would be
that's definitely something for the game developer. And
maybe the game dev needs to, because like we saw one player, he was like, oh, the VPN's not working. I said, turn it off. He goes, it never works. I said, bro, just on the weekend we had an event which had the company was using Network Next. I said, just turn it off and connect again and tell me how it works. He did it and he went, oh, hang on, the ping's better. I was like,
no, that's legit. We can't, when a VPN is kind of like, for something like Network Next, a VPN is pretty much tying one arm behind our back. It's kind of saying, even though you could get me from where I am to 2/3 of the way to my destination faster, it kind of forces most of that hop to be a particular way. And then we can only optimize the last 10%. So I completely believe the experience that you just shared. That's very common. Like if you're running a VPN with a game that's using Network Next, it's honestly better not to, because Network Next will find a better route than any VPN can find.
Right.
Cool. Ben,
interesting.
We've covered a lot of stuff today, everybody. So let's sort of take a quick summary. So we've looked at ISPs and they're firing packets off. They're throwing them upstream in ways where they don't have any real guarantee or knowledge of the path. There's stuff that OneQode is doing, because it was really interesting having the shortest prefix to make it like likely that the ISPs will send packets to OneQode servers the right way, the right path. Network Next is doing something a little more aggressive where we make it happen. Throughout all of it, we're talking about network neutrality and the fact that real-time traffic is different to non-real-time traffic. Any closing thoughts, Ben, before we wrap up for today?
I don't think I've got any, no.
Cool.
I think that's it.
Well, we've covered it. We've beaten it to death. And now everybody knows way more about how the internet works than you've ever wanted to know. TLDR, the internet doesn't care about your game and is not picking the lowest latency route. You get inconsistent performance from one day to the next, and it's just how it works. So Ben, you guys are doing what you're doing at OneQode. I like to think of you guys as attacking it from the network up. At Network Next, we're kind of coming at it from the application layer down. Application down. We meet in the middle. And let me just finish with a nice little spruik for OneQode. Check out OneQode.com. These guys are building an amazing network in the APAC region with server hosting centrally located in Guam. And also, hey, check out Network Next. That's what I'm working on. We're an SDK that integrates in your client and server of your game, and we pretty much force the packets to go the right way. Okay, cool. That's it for the show today, everybody. Have a great day, and see you in the next show. Cheers, everybody.
Here's the hard truth. The internet doesn't care about your game. After all the blood, sweat and tears you put into making your game, you launch, and some players get terrible network performance. What can you do about it? Build your own internet? This is why we created Network Next. Network Next is a radically new way of linking networks together. It's a new internet. One where networks compete on a neutral marketplace to carry your game's traffic. Network Next puts you, the game developer, in control of the network. We monitor every player's network performance, and you choose when to accelerate them. Not only will you see better network performance for your players, you'll also have the security of knowing that if one network is congested, we switch to another in seconds. Now you control the network.